To practice, I'd like to share with you another example, but this time I'd like you to answer some questions after I shared with you this example. The design team had 2 weeks to complete the schematic design phase of their projects. In this phase, they make important decisions about the building orientation, facade, core, and so on. Typically, the design team sends the research team the latest design decisions that they want to make and walk them through the design parameters they have. For instance, let's say they want to design a facade that is fixed in four corners, but they can change the curvature at the center within a specific range. The research team takes in this information and create various design alternatives quickly. The challenge is that the research team only has 24 hours time because the entire schematic design process is only 14 days. Even though they can create thousands of solutions, they only have the time to run energy and daylighting simulation on only 60 of them during the 20-hour time limit that they have. Since these calculations takes a lot of time, they rely on the best practices and intuition rather than systematic design explorations. That's why the simulation time becomes a bottleneck in creating better design solutions. They need to reduce the time of simulation to explore more and find high-performing building solutions. Otherwise, their buildings will produce more carbon, consumes more energy, and have poor lighting conditions, which brings negative impacts on the health and well-beings of occupants. Similar to the structural engineering example, by providing enough examples from the input and enough examples of the output, the machine learning model can learn the process that connects the input to the output. In terms of 5Bs, again, it's very similar to the social engineering process. In terms of volume or scale of data, they use about 1,000 buildings in this example. In terms of velocity or speed of data generation, each data example can be generated in 20 to 30 minutes. In terms of variety or forms of data, this type of data is under the category of computer generated or synthetic data sets. Typically, researchers run automated scripts that instruct the simulator to generate this data. And in terms of veracity or quality of data, typically the quality of synthetic data depends on the diversity and similarity to the real-world buildings that the AI system will be used for. And in terms of the value of data, the team captured data that's aligned with their innovation strategy in their core competency area, designing high-performing buildings. Now, think about the AI system interaction. Based on what you learned so far, what is the desired level of autonomy? Perhaps should be level 2 because designers can quickly make informed decisions and find the solution. And think about the limitations of the AI system. We know that there are three inherent limitations of the AI system. And the question is, how should we prepare our data set and AI system for it? In terms of causation, what are the things that are causing the output? What's your plan in capturing those? How do you consider for counterfactuals? What are the building parameters that you consider in terms of dimensions, number of stories, the climate zone that the building is located at, and so on? And what are the constraints that you put into the AI system so that it can give you the best design option or solution or recommendation?